Welcome to lecture number 4. This is Mathematics 164 Precalculus. In lecture number 4, we are going to discuss about radicals and also rational expressions. So how to calculate radicals and rational expressions. First, we want to go through what is a root. Example, square root, cube root, etc. So an example here, we are given s raised to the power 3. The opposite of s raised to the power 3 is the cube root. So what we mean is that, for example, if I have 8, 8 is the same as 2 to the power 3. So 2 to the power 3 will give me 8. Then the cube root of 8 will give me 2. So that's why here we said from geometry, we know that if an edge of a cube has a length of x, its volume is s cube units. Now, reversing this process, we determine that if the volume of a cube is v cubic unit, then the length of an edge is the cube root of v, which is denoted as following. So again, if it's 8, then the square root of cube root of 8 will give me 2. And that's the example here. So the cube root of 8 is 2. So 2 raised to the power 3 is 8. And normally we use the expression, so here we have n root a, we call it radical. So the expression root n a, or it can be any number, is called a radical. So when we have algebra expression with a radical sign, we call it a radical expression. And the principal nth root of a real number is defined as root n a equal to b. This is only if a equal to b to the power n. Example again using the 3. If I have a cube root of 8, the answer will be 2. Why? Because 2 raised to the power 3 is 8. And that's the rule here. Also, if our n value is even number, then if a is a negative value, which is a is less than 0, then there's no solution, or it's not a real number. But if it's an odd number, it's okay. So what I mean is that, for example, square root, which means 2, even number, square root of negative 4, the answer is not negative 2. There's no answer. But cube root of negative 8, the answer will give us negative 2. And that's the rule here, the condition. If the root is even number, then we can't get a value less than 0, or a negative root, there's no solution. If it's a odd number, that's okay. So that's example here. Here they say we should find the root of 64, and then negative square root of 16, cube root of negative 8, and square root of negative 16. So let's go through the solution one at a time. So here, since we know that 2 to the power 6 is 64, then we know that 6 root of 64 is equal to 2, because 2 to the power 6 is 64. The next one, the negative does not affect, it's not inside the root or the radical, in this case square root. So this is okay. We can write it as following, and we can find the square root of 16, which is 4. Then we had a negative. Why is it 4? Because 4 squared is 16. Another example here. Now here, since our n value is odd number, in this case 3, cube root we can find a solution. So the answer will be -2. Now, I have square root, which means the value n is 2, even number. So here we say it's not a real number because an even root of a negative number is not real. So we don't have a solution. So next we do the fractional exponents. We already stated that here we say a should be greater than or equal to 0, and also b should be greater than or equal to 0. So if I have a square root of a equal to b, it means b squared is a. We already stated this in the previous slide. And that's what we say here also. So square root of a or square cancel the square root. So the answer will be a. Again, square root means a power. That's what we say the fractional exponent. Square root means raised to the power of half. So half times 2, we did the exponent rules. If I have a half exponent raised to 2, I will multiply 2 by half, and that will give me 1. Now, cube root is 3, so it's raised to the power 1/3. And that's what we said here. So square root of a is same as a raised to the power half, and all square, so square. So we know the rule of exponent, half times 2 will give us 1. So a raised to the power 1 is a. So if we have a positive integer n, we can define that a raised to the power 1 over n is the root of n, a. Only if a exists or if the expression exists. The reason why we said this, for example, if n is 2 and a is negative, let's say -9, then there's no solution. It's not a real. And we saw the rule of exponents. So I have a raised to the power 1 over n raised to n again. So 1 over n times n will give me 1. They will cancel, and will cancel each other. So it's a. So rational exponent always will be more or less a fraction. So if I say a raised to the power n by n is the same as saying a 1 over n times m. So it will be root of n, a to the power m. So our definition of a raised to the power m by n, or m divided by n, guarantees that the rules of exponent will apply to the fractional exponent. So this is the same as writing m times 1 over n. So this is some few examples here. So here we are going, since the base is the same, we are going to add a half plus 1, 6. So half plus 1, 6. And that will give us 1/3, 2/3, sorry. So we can see half, again, exponent rule, the base is the same. So we had exponent because it's multiplication. So half plus 1, 6. The LCM will be 6. 2 can go into 6 is 3. 3 times 1 is 3. So that's why we have 3 here by 6. 6 can go into 6 is 1. 1 times 1. So that's why we have 1. Now, since the denominator is the same, we combine the numerator. 3 plus 1 is 4. So we get 4, 6. And 2 can go into 4 and 6, and that will give us 2/3. The next example, we have a 3/4 divided by a raised to the power 1/3. Again, the base are the same, and we are dividing, so we subtract the denominator exponent from the numerator exponent. So we get a 3/4 minus 1/3. And here we can also find the LCM, 4 and 3, that will give us 12. 4 can go into 12, that is 3. 3 times 3, that's 9, so we get 9/12. And the same thing here, 3 can go into 12, is 4. 4 times 1 is 4, so we get 4/12. Now, since the denominators are the same, 12/12, we combine the numerators. So we get 9 minus 4, and the answer will be 5/12. The next example is rules of exponent again. Since we have a to the power cube b in a parenthesis raised to an exponent of power to third, we are going to multiply to third with other two, everything in the exponent, in the parenthesis. So we get a cube multiplied by 2/3 times b to the power 1 times 2/3. So we get this. Now 3 will cancel 3. So we get a square b 2/3. The next one, we have a to the power 3 by 2 to the power half. So we have two powers. So we multiply 3 by 2 by 1 by 2. So that will give us 3 times 1 is 3, 2 times 2 is 4. So that will give us 3/4. And this is the same thing also, multiplication. So we had the exponent, the base are the same. So we get negative half plus negative 3/2. Plus and negative will be negative, so that's why we have negative here. Now, since the denominator is the same, we combine. So we get negative 4 by 2, and that should give us negative 2. And we can do the reciprocal of it, and that will give us 1 over a squared. So next we move to operations with radicals. So these are the rules for radicals. Now here we are giving root NA and root NB are real numbers. So this means if I have a root n, a raised to the power n, as we said earlier, root is reciprocal. So n means 1 over n. So 1 over n times n will cancel each other, and that will give us a. And here also we have a and b. So here the base are different. We cannot just combine, but we can multiply. Now, since the root is the same, n and n, we can just multiply a and b. So the root affects both of them. Now here also the same thing. The roots are the same, n root, n root. So n root a divided by n root b, we can combine together. So we say root of na by b. So a very good example here, we have a square root of 18 divided by square root of 2. Since both are square root, we can just have square root of everything, 18 divided by 2. That will give us square root of 9. Square root of 9 is 3. Here the base, we have 2 and 4. The root is the same, cube root. So I'll just multiply 2 by 4, 8, and keep the cube root. And then we know the cube root of 8 is 2. Here we have fifth root, 6 raised to the power 5. So we know the fifth root is 1/5. So 1/5 times 5, because exponent over exponent, and that will give us 1. So the answer will be 6. So this is an example. We are going to consider the first rule now. I have square root of negative 2 raised to the power 2. The answer is not equal to negative 2. Why? Because we can see that the square is also affecting the negative. So negative square is negative times negative. That is positive. So our answer should be 2. And that's what we have here. So since it's negative 2 square, that will give me positive 4. Square root of 4 will give me 2. Here also we can generalize this observation as follows. If a is less than 0, then square root of a square equal to negative 1 greater than 0. So square root of a square equal to a only if a is greater than or equal to 0, or equal to negative a if a is less than 0. This means square root of a square is what? Absolute a. And root 2, we have a root n a times root n b. So the radical is the same, n. So we multiply a by b, and everything will be on root n. This is root 2. So that's the example we have here. We have keep root 2xy, keep root 4x squared y. Now, the root is the same, 3, 3. So I can just multiply 2 by 4. That will give me 8. S times s squared, I will add exponent, so 2 plus 1, that will give me s cubed. Y times y, which means 1, 1 is 2, so I'll get y squared. B also the same thing, we can see square root, square root. So just multiply all the terms, and we'll see the solution here. So again, the answer will be 4. We haven't finished yet. So it will be 4 times 2, which is 8s cubed y squared. So we break it down. This is the question. We combine the two together because the root is the same, 3. Now, if I have square root, I cannot combine because the roots are different. But yes, since both of them are keep root, we put everything together and multiply everything. Now, in the B, here what we are trying to do is that we are trying to remove again, we did all the multiplication here, but we are trying to see if we can simplify some of the terms outside the. Now, since this is 3 and I have a s cube, then s cube times 1/3. So the cube will cancel the cube root. So that's why we have x outside. 8 also is 2 to the power 3. And since I have a cube root, which is 1/3, 1/3 times 3 will give me 1. So that's why we're able to take the 2x out. But y we couldn't because it's 2 and 1/3. So we leave the y. So the final answer will be 2x cube root of y squared. The B, again, the same concept. We have square root, square root. So we combine the whole terms. 8 times 4 is 32. S times s squared will be 2 plus 1. So the exponent will be 3. Y cubed times y 6. And y, so 3 plus 6 is 9. Oh, sorry, 3 plus 3. Y cubed and y cubed, so 6. Then z squared is 3, so z. And here, if you like, you can see if we can be able to simplify something out. And we were able to do that because we know 16 times 2 is 32. And 16 square, here is a square root, so we need squares. So I'll get only 4. And then s square and square root, so x go out. 3 times half, so y cube will go out. Z square, so 2 times half will be 1. So the remaining will be, of course, here we break it. Remember the s is cubed, we take 1 out and we keep the 2 to cancel half the exponent. So the final answer will be 4s y cubed z square root of 2x z. So next we move to rationalizing. Now, the concept of rationalizing means a question will be given to us and the exponent doesn't matter, but there will be a radicals at the denominator. So our goal is to remove the radicals. So this is a very simple example, rationalize the denominators. So express the following with no radicals in the denominators, and that's what we mean. So 15 divided by square root of x, the only way I can take the radical sign away or take the square root away is to multiply by square root again, because square root multiplied by square root will give me square root of x times square root of x will give me square root of x squared. And now since square root is half exponent, we have half exponent times 2 will be 1. So let's look the solution, maybe that will be more better. So this is our question, 15 divided by square root of x. So I'll multiply by square root of x, because the goal is to remove the radical sign from the denominator. And that's the only way, because square root of x times square root of x will give me x. Then we're going to get s squared square root. So we get half exponent times 2. Now the top we don't care, so we have 15. Now, if I multiply any value with the denominator, I have to do the same thing to the numerator, so that I'll balance the equation. So since I multiply the denominator by square root of x, I have to multiply the same square root of x to the numerator, so that the expression will be balanced. So our final result will be 15 square root of x divided by x. This is another example also, which is the B. So this is the question, 2x divided by square root of 18xy. So the goal here is to remove the square root. So we decided to multiply by square root of 2xy. Why? Because I will get 2 times 18 will be 36, which is 6 square. So 6 square and then raised to the power half, 2.5 will cancel. And also we get x squared, which is again half times 2, y squared, which again 2 times half also. And that's what we have here. So the final solution is to take the radical sign from the denominator. 6 squared, x squared and half, so x, and y squared times half, so it will be only y. And now this will be our final solution, because 2 divided by 3 will give me, and also the x here will cancel the x. So final answer will be square root of 2xy is square root divided by 3y. Again, 2 divided by 3 will give me 1/3, so 3 down. X will cancel x, and we still have y, so 3y. Next, we wish to create a perfect cube under the radical in the denominator. So this is our question again. We have 3x divided by cube root 2x squared. The goal is to take out the cube root. So if I have 2 here, I need 8. So I multiply by 4. And if I have 2 here, I need 1 more, so I multiply by x. So whatever I multiply by the denominator, I have to multiply at the numerator. The goal is that when you have a question like this, you have to look at the value of the root and see if the value of the root is even or odd. It doesn't matter. But for example, here we have a 3, which is odd. But I have 2 here. What number that if I multiply by itself 3 times, it can give me some number. And that number, we can cancel the 3. The cube root is 1/3, so I need a 3. So the only way is to make this 8, so that I'll get 2/3 times the exponent will be 3, for 2/3 is 8, times the cube root, which is 1/3. So that will give me 3 times 1/3 and 1. So that's why we use 4, because 4 times 2 is 8. So that's what we have here. Now we can get 2 to the power 3, and cube root is 1/3 times 1/3. X to the power 3 times 1/3. So you can see the cube root and the cube will cancel each other. So our final answer will be, the down will be 2x. The goal is again to take the radical sign from the denominator. Here x will cancel x, but 3 cannot, 2 we can cancel, so we leave it 3, 2, then cube root of 4x. So this is another example. We have 5x squared divided by cube root of x squared. So the goal is to find a way to take the cube root out. Okay, so since I have only x squared here, then the main goal here is to have the same expression. So we have cube root x squared squared. Since what I did at the bottom, I have to do the same at the top. We did it. Now, when we combine, this is what we get. Then we can see that the 3 will cancel 1/3. We get S squared down. Another example here, which is our last example. We have x squared y plus square root of x squared plus y squared. Now here the goal is that we have y plus square root of x squared plus. So we are going to use the difference of two squares. If I multiply by y minus square root of x squared plus y squared, what happens is that I'll have a difference of two squares here. So it will be y squared minus square root of x squared plus y squared all square. So the square will cancel the square root. And that's what we have here, y squared. Here we are using the difference of two squares. A plus b times a minus b is the same as a squared minus b squared. That's what. So our y will be our a. So we get a squared. Then square root of x squared plus y squared will be our b. So we get b squared. Again, the goal is to remove the radical sign. So we can see the square will cancel square root. Then we have some like terms here. So we can combine y squared minus x squared minus y squared. So y squared minus y squared will be 0. So we'll be left with only minus x squared. And that will be our final solution here. And actually here we can cancel x squared. We'll cancel minus x squared and it will left with negative. So our answer will be negative, parenthesis y minus square root of x squared plus y squared. So again, in this lecture, we go through what is radical expressions and also how to rationalize denominator in algebraic expression. So again, wish everybody their best. And next slide, we are going to cover limits. So see you then. Thank you.